Okay, so the first question says, prove that 1 upon x plus 1 plus 2 upon x squared plus 1 plus 4 upon x to the fourth plus 1 all the way till 2 power n upon x to the 2 power n plus 1 is equal to 1 upon x minus 1 minus 2 up to the power of n plus 1 upon 2 to the power of, x to the 2 to the power of n plus 1 minus 1. Right, so looking at this thing, it seems as if this has been telescoped to get this as the first term and this as the last term. So how can we get this as the first term? I think an obvious thing to be done would be to multiply x minus 1 on the numerator and the denominator to get this expression. Okay, but now we want to get rid of the x plus 1 of this factor. X plus 1 as a factor of this thing. We want to get rid of that. So how can we do that? We can do that by adding an x plus 1 additionally to it and then subtracting 2, right? So upon x squared minus 1. So this minus that, that's exactly this thing. But what we just did was that we introduced this x plus 1 over there, and now when we expand this thing, we will get x plus 1 upon x squared minus 1 minus 2 upon x squared minus 1, which is equal to 1 upon x minus 1 minus 2 upon x squared minus 1. Okay, so here we did two things. First of all, we introduced this additional x plus 1 to get rid of the x plus 1 which was originally in the denominator, and then what we did was that we introduced this 2 over there. And the good thing about that is that you can see that the numerators are in fact in a geometric series with the ratio being 2, so we might just be able to find some symmetry over there. So let's try to think what would happen to the next term. So 2 upon x squared plus 1, if we multiply x squared minus 1 on the numerator and denominator, that will give me 2 into x squared minus 1 upon x to the 4 minus 1. Okay, but now we want to do a similar thing with that term as well. So 2 into x squared minus 1 then can be written as x squared plus 1 minus 2 upon x to the 4 minus 1, right, which will be written as 2 into 2 upon x squared minus 1, because this and one of the factors of this cancels, then minus 4 upon x to the 4 minus 1. So you can already see where the pattern is going. This term and that term will be the same. So in general, if you have any general term, say 2 to the r upon x to the 2 to the r minus 1, what we are going to write it as 2 to the r into x to the plus 1, sorry, x to the 2 to the r minus 1 upon x to the 2 to the r plus 1 minus 1. Okay, cool. But then that thing can be written as 2 to the r times x to the 2 to the r plus 1 minus 2 upon x to the 2 to the r plus 1 minus 1. So that is 2 to the r, and then over here you have that one of these factors will get cancelled. So 2 to the r upon x to the 2 to the r minus 1, then minus 2 to the r plus 1 upon x to the 2 to the r plus 1 minus 1. So you can see that both of these expressions are symmetric and that they are in a difference. So that means that this series can telescope very easily. Okay, cool. So let's just clear some space and move some stuff on the front. Okay, so up till now we have done this thing, right? We know how to deal with every term and then make this into a telescopic series. Let's do it now. So we can write our summation for tr from r equals to, let's see, 1, right? No, wait, not 1 exactly, it's r equals to 0 maybe. So yes, r equals to 0 to r equals to n, right? That looks correct. So that's supposed to be equal to, when you put 0 in there, you get 2 to the 0 upon x to the 2 to the 0 minus 1 minus 2 to the 1 upon x to the 2 to the 1 minus 1. Then you get, when you put r equals to 1 in there, you get 2 to the 1 upon x to the 2 to the 1 minus 1 minus 2 to the 2 upon x to the 2 to the 2 minus 1. And you can see that the pattern will come out naturally, and then For the final term, we will put n in there, so that will give me 2 to the n upon x to the 2 to the n minus 1, and then minus 2 to the n plus 1 upon x to the 2 to the n plus 1 minus 1. So yes, stuff cancels out. You can see that this will telescope, and then this term and that term will be the leftovers, so that will be 1 upon x minus 1 minus 2 to the n plus 1 upon x to the 2 to the n plus 1 minus 1, which is exactly what we had to prove. Okay, so the first question is done. Let's move on to the next question. So it is a similar flavored question, where we have to use telescoping and a similar kind of concept. So find the sum to the first n terms of the series 1 upon 1 minus x into 1 minus x cubed plus x squared upon 1 minus x cubed into 1 minus x to the fifth plus x to the fourth upon 1 minus x to the fifth and 1 minus x to the seventh. And we are given that x is not equal to 1 minus 1 or 0, because then the denominator or the numerator would vanish, so that's not good. Okay, fine. So unfortunately we are not given something like that over here, so we cannot guess how this is going to telescope based on our result. So we need to come up with something completely new, and what I initially thought, and I am still thinking about that, is that x to the fifth minus x cube, that is nothing but x cube into x squared minus 1, and then similarly x to the seventh minus x to the fifth is x to the fifth times x squared minus 1, and then x to the ninth minus x to the seventh, that is x to the seventh times x squared minus 1. So you can see that x squared minus 1 is a constant everywhere, and then you have this x to the fourth, which is just 1x less than this thing, and then x squared is also 1x less than this thing, and then x to the seventh, you will have x to the sixth over there, right? So that will be x to the seventh, but without 1x. Okay, fine. So what we can do is that we can multiply every numerator by x into x squared minus 1, and at the same time we will take 1 upon x squared minus 1 into x common. So maybe that will help us telescope something. Okay, fine. So this series, this can be written as 1 upon x squared minus 1 into x, and then on the top you will have, first of all, x cubed minus x upon 1 minus x into 1 minus x cubed, then plus, for this you have x squared, which is x to the fifth minus x cubed. Okay, right, so you have x cubed minus, okay fine, that works, x cubed into x1 minus 1 is just x to the fifth minus x cubed upon 1 minus x cubed into 1 minus x to the fifth, then plus x to the seventh power minus x to the fifth upon 1 minus x to the fifth, and then 1 minus x to the seventh. Okay, and it will keep going like that, and we have to find the sum to the first n terms of the series. We don't care about what the last term is yet, so let's see what this gives us. X1 minus x, okay, fine. The first one, we can write x cubed minus x as 1 minus x minus of 1 minus x cubed. So when we will break the fraction, what we will get is 1 upon 1 minus x cubed minus 1 upon 1 minus x. So it's the next term minus the previous term. Okay, fine. Then you have 1 upon 1 minus x to the, wait, what? Okay, 1 minus, fine, that looks correct, 1 minus x to the fifth power minus 1 upon 1 minus x cubed, then 1 upon 1 minus x to the seventh power minus 1 upon 1 minus x raised to the fifth power. Right, you can check that this is happening, because it's x to the fifth minus x cubed can be written as 1 minus x cubed minus 1 minus x raised to the fifth. Okay, so then it can be expanded like this, and then similarly the next term can be expanded like this. And now we care about what the last term is going to be. So let us see. You have x to the first power, then x to the third power, then x to the fifth power. Yes, That looks correct. So like these factors, uh, these are over here. Okay, fine. So what's the nth term of this series? So you have the series 1, 3, 5. What's the nth term? It's going to be 2n minus 1, right? So for the last term, you will have 1 upon 1 minus x to the 2n minus 1 over there. And similarly for this, you will have 2n plus 1, I think. Yeah, that's correct. So 1 upon 1 minus x to the 2n plus 1 power minus this thing. So that will be our series. And then this will telescope. Okay, cool. So you will have x cubed cancelling with x cubed and x to the fifth with x to the fifth, and this will telescope completely, and then this will get also cancelled. Nice. So this is 1 upon x into x squared minus 1 into this thing, which is 1 upon 1 minus x raised to 2n plus 1 power minus 1 upon 1 minus x. Okay, cool. So I don't think we need to do anything more to that thing. That's it. So no more simplification. I think that's the final answer. So cool. That's the sum to the first n terms of this series. I will see you in the next video.